learning target 5.8 or 5.8 is determining how many solutions a triangle will have, and then using the law of sines and law of cosines to solve them. So this first video is going to be just looking at the law of sines. And so right off the bat, we've got the definition that says the law of sines will work with any triangle ABC. So ABC are representing the side lengths. Remember, the lowercase letters are always the sides opposite the angles with the capital letters of ABC. And then you've got the law of sines, and I believe this is something that you've used before. And this law of sines is used when you have a triangle where there's two angles and any one side, or if you have two sides and then the non-included angle. And we'll talk about exactly what that means, including the ambiguous case. Okay. So before we just use this rule, I want to show you why it works or how it works. And so if we're given this triangle A, B, C, and that triangle is not necessarily a right angle, so we don't know that that's a right angle, we don't know that's a right angle or that's a right angle, it doesn't matter, we'll still be able to use this law of sines. Okay. But law of sines, you need the hypotenuse. So you have to have sine is opposite over hypotenuse. So where are we getting this hypotenuse if we don't have a right triangle? And so you can take one of the sides and drop down what's called an altitude, or we can call that the height of this triangle. So you can think about this as the base, and that's the height. And now we end up with two right triangles. Okay, so if we look at, let's just look at this left-hand side of the triangle. So if I use that triangle, this is my hypotenuse, and this is my opposite side. Okay, so why does it work? Because we can say that the sine of A, remember sine is opposite over hypotenuse, so that would be opposite h over hypotenuse b. So it would be h over b. Okay, so the sine of A is h over b. Or we could use the law of sines in this triangle, or the sine in that triangle. And now if we use angle B, we still have h as the opposite side, but now this becomes the hypotenuse. So because we're using opposite and hypotenuse, I can still say that the sine of B is now our angle, would be opposite h over hypotenuse, which is A. So we're going to use those two equations to somehow get back to what this law of sines is saying. We have three different variables in each equation. So we've got angle A, side B, angle B, and side A. And the one thing that's in common is that they both have this h. So I'm going to solve each equation for h. So if I want to get h by itself, I have to multiply by b. So I get b times the sine of A equals h. Or in this one, I can multiply by a. So I have a times the sine of b equals h. Okay. So now how do we take those two equations and go back to where the law of sine says that a over the sine of A equals b over the sine of b? Because both of these equations equal h, and h is the same height in this triangle as it is in this triangle, then b sine of A has to equal a sine of b. So b times the sine of A has to equal a times the sine of b. And then how we got up to the form that's at the top is by saying, let's get rid of the sine of A. So then we have to divide this side by the sine of A. So now we have b equals a sine of b over the sine of A. Now we've got both a's on one side. If we want both of the b's on the other side, we have to divide by the sine of b over here, and divide by the sine of b over here. And now we end up with a over the sine of A on the right equals b over the sine of b on the left. And so it'll work whether we chose to use A, B, or C. And so likewise, then you can say that that's true for all three of them. You can also flip it over and say the sine of A over A equals the sine of B over B equals the sine of C over c. So it doesn't matter which one is on top and which one's in the denominator, it just, you have to keep it consistent. So in this example, it says find the length of AC and BC correct to 2 decimal places. Okay, so the length of AC, I'm going to also call that lowercase letter b. So this here is lowercase letter b, and then the length of BC, we're going to call that lowercase letter a. So we can only solve for one of them at a time, but because I know this angle and I know the side opposite, I can use the law of sines. So let's look at solving for b first. Okay, because we already know the angle opposite of that, we can say that this is solving for AC. And we're going to have to do another one to the right. So solving for AC, we can say that b over the sine of b, which is 58, has to equal, now we have to use the one that we know, so we've got 39 degrees and 12 centimeters. So we'll put 12 centimeters on the top and the sine of 39 on the bottom. Okay. Now you can cross multiply these two and divide by this. So b is going to equal 12 times the sine of 58 divided by the sine of 39. Supposed to be an S, not an 8. And so then we can get this approximate answer that b is approximately 16.17 centimeters. And I would, as always, recommend labeling it on the drawing. Okay. And the last one that we've got to solve for now is BC. Okay. If we're going to find this side length, we need to know the angle opposite. So since we already have these two angles, we can add them up and subtract from 180, and we get 83 degrees. So now we can say that a over the sine of 83 degrees has to equal 12 over the sine of 39. Again, cross multiply and divide. So a equals 12 times the sine of 83 all over the sine of 39. So we can get an approximate answer for a of about 18.93 centimeters. Okay, label it on the drawing. And a good thing to check is that the longest side, aka this one with 18.93, should be across from the largest angle. And the smallest side, or the shortest side of 12, should be across from the smallest angle of 39. So that's a good thing that you can just do to double check. We will cover this one on the next video.